Look at that. We're ready to rock and roll after I quick pause because I forgot to do homework. Did anybody have a homework question? 1-9. We are going to be doing how polynomials can behave in real world situations. Yeah. All right. So, ladies and gentlemen, if I have 1 point, what can I write? Nothing. If I have 2 points, what kind of a graph can I make? What kind of polynomial? Linear, right? If I have 3 points, what can I make? Quadratic. If I have 4 points, what can I make? Cubic. Could it be a quadratic if I had 4 points? Yep, it could. Could have tendencies of it. But with 4 points, I'm guaranteed to make a cubic. Okay? If you have 1 more point than the degree, that will always come out to be perfect. Does that make sense to everybody? Okay? So right now I have 3 points. Okay? 8, 30, 10, 45, 11, 65. Okay? Let's just kind of look at what that looks like by that. Okay, so I'm going by 5s on this data. Okay, so 8, 1, 2, 3, 4, 5, 6, 7, 8, going up 6, 1, 2, 3, right there. 10, 45. And 11, 65. That could almost look linear even, huh? Okay, so it could be a quadratic or it could be linear. So we could go ahead and write an equation depending on what it is. So here's what we're going to do. We're going to pull up the old calculadora. Pull up you dingleberry. Here he comes to save the day. All right. So you guys obviously have the points that I was asking, right? So what we're going to do is go stat. See how it says edit? We're going to go ahead and hit enter. Now, for me, I have a bunch of stuff in here. Does anybody have a bunch of stuff in their L1? Curiosity? If you do, okay, you don't want to hit the delete button, but you want to go up and hit clear. And then hit enter, and then notice it's gone. Okay? Don't hit delete, because it deletes the whole column, and then you can never get stuck with that. And L1's your priority list. I like that one. Okay. Everybody good with me? All right. What was the coordinate? 8, 30. So I'm going to hit 8, enter. Come on, you speaker winker. Okay, what's the next one? 10 and 11, correct? All right. Now I'm going to go over into L2, and I'm going to put their designated Y value with them. Okay? Is everybody with me on that? And it was 8, 30, is that correct? 45, I believe, and 65. Once again, those are just the XY coordinates. Okay, XY coordinates of the points that were given. All right. Now, it's been a while, so I'm going to have everybody hit second catalog. Oh, I got to remember what that's called. Diagnostics. Okay. So look here. I'm going to look for D. Where's D, guys? Right here. See it right there for me. In the letter it says D. I'm going to hit D. And it jumped all the way down to the D's. So I'm just going to scroll down. See where it says diagnostic on? Go ahead and hit enter on that. It just makes sure that we have all the information that we're needing. It pulls us back to the main screen. Hit enter again, it should say done. Once again, everybody diagnostic on. Once again, this is for TI material. If you're using another one, you might not have to do that. Once again, Google flash your book. Okay, but it can be written now. Okay, is everybody with me there? All right. So we're going to go back to our stat. This time we're going to go calculate. I'm going to push over. Okay. I have one variable test, two variable tests. What do you guys think I have? Well, it's none of those actually. We're going to go down to linear reg, quad reg, qubit, quartic, and so forth. Okay. So really the highest we can go is a quartic. So I'm going to scroll down to a linear regression line. That's what that stands for. Okay, just basically like a line of best fit. Okay, I'm going to hit enter. Now, if you have an older TI, like a TI 83, or yes, while you, I've just okay. So it has L1, L2, because isn't that where I put my information, is in L1 and L2? What if yours didn't say L1? What would you have to do? You change it, right? By the way, if you look above numbers 1, 2, 3, all the way up to 6, they have all the L1s all the way up to L2. So if you need to switch it, you would switch it now to L1 and L2, or whatever designated that you put the information in. Some of you guys might have put it in L3, L4. Does that make sense? Is everybody with me on that? Okay, so Sydney, yours didn't pop up, right? Okay, and it's okay. It's designated as maybe L1, L2, but I'll help you if not. Okay, so I'm going to hit enter, hit enter, hit enter, and then I'm going to hit calculate. Okay. So this basically, ladies and gentlemen, what did it do for us? It wrote the equation of the line. Okay. As I go back here really quick, you guys all maybe have the exact same information I do. The exact same Nicole does. Okay, for sure. Okay. So some information that it gave us was, here's an equation of a line. Y equals ax plus b. We usually say bmx plus b, right? But it's okay. This is an equation of a line. What was the a value that it gave us? 11 what? 11 point, let's go second digit, take it, 07. X plus our b value would be? And once again, that just came from the calculator, right? Now, what does the stuff below it mean? R squared and R. Well, the closer it is to 1, the better the line's going to fit. So this was 0.96. That's pretty good, huh? Does that mean this is a direct linear equation? No. But it has good correlation, huh? The closer it gets to 0 means less correlation. And if it gets closer to -1, what does that mean? Instead, this guy has a positive slope right now, we saw, right? If it was closer to -1, it'd have a negative slope. That's the only difference. But the closer that R value gets to 0, the less likely it is that equation. Does that make sense to everybody? And as 0.96, was it pretty close to a linear equation? Really, let's look at this for a moment. Okay. Take a little gander. That looks pretty linear, doesn't it? If I continue on, maybe it would cross at -60 if I'm going down the increment to 5, right? Does it seem realistic? Yeah, okay. But is it the best one? Well, we already know for sure that at this time, if we have 3 points, what's automatically going to be given to us? A quadratic's going to come out perfect. Because you need to have 3 points to make the quadratic. So let's go switch back again. Go back to the calculator. And instead of this time a linear regression, we're going to do a quadratic regression. So where's that at again? We're going to go ahead and hit stat. Calculate. So over. Down this time to number 5. Hit enter. L1, L2 in this case. But look at our r squared. Is r squared what we're looking for, or is r what we're looking for? Technically r. But what's the square root of r squared? It would come out to be 1. Okay, so it would be that it is perfect. Okay, so once again, you guys have this information? You got this? Okay, so I'm going to go back and we're going to write the equation this one. Okay, so what would be the equation of when it is a quadratic regression? It'd be y equals, who is the a value? 4.16, okay, x squared get so frustrated. Plus or minus then, or was a minus? Too big. Okay, then last number. Plus 303. All right. Notice that would be the equation of a perfect quadratic if that came in. Noticing, meaning it would kind of come like such. Okay? Not necessarily that exactly, but we get the idea. Okay? So, once again, though, we can look through and kind of figure out which one's going to be best. Now, what's always going to be perfect? So if I have 4 points, what's going to come out perfect every time? I'll have a cubic with an r squared of 1, which is an r of 1, because 4 points gives me a cubic. Does that make sense to everybody? So sometimes you might even want to look into the problem and say, hey, does this really make sense? Can something be in this cubic model, or should it be more of a quadratic? Okay? But that's really what we're doing today, is writing equations of lines and then using that information. So let's just say we are going to use this quadratic right here. Everybody there with me? Okay? So let's say I wanted to use him, and I wanted to know what happens when x is 12. You guys want to plug it into this formula? No? So it's been a while. I should have studied this a little bit before, so bear with me here. Oh, get down there. Okay, so I got to remember. It's been a while. Think, 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 think. Is it stat? No. 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 Maybe I'll push pause and go ask Miss. Okay, so we're going to go y equals. If something's in there, clear it out. Yay. So we just barely took the regression, right? So what we're going to do is, it was in bars. Then go down to number 5 and do statistics. Over to EQ, which is the equation. We'll do a couple of these so it gets in your memory, okay? And then we hit enter. Notice it plugged it in for us. No problem. So once again, I started it. Let's clear it out. Okay, so I went y equals, which I'm in currently. Hit the bars button. See number 5 where it says statistics? I know there's an easier way than this. I can't remember, so I'm going off of what. So, you see the EQ? Does this have it in your city? And then see how it says reg equation? That's your regression equation that we just found. So hit enter, and it puts it in for you. Now, why is that nice? Because, ladies and gentlemen, watch as I go to my table. What number was I looking for when x was 12? So I'm going to go scroll up till when x was 12. That's taking forever. I know an easier way, so I might show you that. So I have 93.33. Ah! Maybe I hit the button too many times. Shush your mouth, that does over half. Okay. 93.33 would represent the value of when x is 12 using the cubic model. Okay, another way to do that is to hit graph. I'm just going to hit graph. Now my window might not be appropriate. No, so might want to do a little window a little bit higher. Let's go all the way up to 100, not 1,000. See if we get a better graph. There we go. So we have our quadratic, right? So what I could do here is after you get the graph, is I go ahead and hit second, calculate again. You see how it says value? Hit that. And what's the x value I want to plug in? 12. And I'm hit enter. 93.3. Okay. So instead of having to plug it back into the function, which is kind of nasty, right? To be doing kind of even a synthetic with those numbers because they're not the prettiest of numbers. I'll let the calculator do the work for me. Okay? Does that make sense to everybody? Okay. So let's go back here. Let's do another one. Okay. So okay. So this one's talking about a population of a city in terms of their year. Okay? So one thing that you always need to know is understand who's the dependent and who's the independent variable. Does population depend on what year it is, or does the year depend on how much population there is? The population depends on what year it is. You guys agree? So whoever is dependent, the population is dependent, that's your y value. Okay? Whoever is independent is the x value. Okay? Everybody there with me? Now, maybe I don't want to have to graph 2004, because then that makes my numbers really big. What could I say instead? That this represents just 4, 7, 9, and 10, right? Wouldn't that be a whole lot nicer to use? But if I asked you to find the population in 2022, what would you have to understand to plug in for x? I'd have to plug in 22. Does that make sense to everybody? Okay, so right now, which equation do you guys think should be the best? How many points do we have? 4. So therefore, we automatically know a cubic's going to be probably the best one that has the perfect. But let's go through the quadratic and the linear just to check as we speak, just to see what the R values are, okay? So that's going to be my goal, because as soon as you plug it in, it's really not too hard. Okay, so once again, I'm going to hit Stat, Edit. Notice I have information in there, so I'm going to go up and I'm going to hit Clear. And I can push over and on or Enter. Okay, up, clear, enter. So it's just an easy way. Remember not to hit delete, hit clear. And once again, if you have a TI 86 or 85, let me see. If you have one of those other ones, Google is your friend. Okay. Or you can look at it a little bit later today. All right, so here's the equations. Once again, I'm not going to do 2004. I'm going to just do 4. I believe it was 7, correct? 9, and 2010. Okay? Who corresponded with 4? 475? Okay, somebody was dyslexic. if you are dyslexic. I'm not trying to be rude. My friend, he got a scholarship for dyslexic. Might be worth it. 2007. How much? 910. Okay, how about not 2009? 1244. And last but not least, 2010. All right, so let's go through this once again. So I'm going to go second quick because I want to be back at the main screen. What was the last one we just used, by the way? In quadratic progression. Okay, let me show you guys a trick. I don't know if you guys knew this. If I hit second, enter, you guys know it pulls back the last thing you just typed in? So if you ever do, like, maybe you need decimal points for, like, the quadratic formula, right? You know, you have to do plus and minus. I just hit second enter, and then I go switch instead of negative b plus. I go back and do negative b minus. I switch so I don't have to type the whole thing in. Does that make sense to everybody? So I've already got the quadratic one, so we're going to go ahead and hit enter. That's actually pretty good, isn't it? 0.995? That's actually really good data. Okay, so notice, you guys have that in the that I can jump over? Sometimes it might be just an off by you pushing the number, or I push the wrong number. Those are pretty good numbers. Okay, so I'm going to come back over, and we're going to write that equation down. So for a quadratic one, I had y equals, who's the a value? Just negative 4. X squared, the b value, 203, plus, minus. All right. That's pretty good quadratic regression, huh? Okay, let's go ahead and go back and look at the linear regression. By the way, the r value, well, our r squared was 0.995. So if I want to know what the r value is, what would I have to do? Square root. Somebody do that for me. Just quick and easy. Square root of 0.995. 0.997. That's pretty legit, isn't it? But obviously the cubic one's going to be nice because it was 4 points. It's going to be r is 1 because of 4 points. But could it be a quadratic? Does it have quadratic tendencies to it? It does. Let's try the linear one really quick. So where do we go? Somebody tell me, how do I do that? Stat. Calculate. Number 4, linear regression. Now, when my calculator pulls this up, who has a TI-84 that doesn't pull this up? If you have a TI-84 that doesn't pull this up and you like that, come over to me after school, we can change it and I can get you that to a newer interface. Okay? As long as you bring somebody or like yes, closer. Yep, love you all. Enter, 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 enter! Calculate. Look at that R, 0.996, but is as good as the quadratic? The quadratic was 0.997. Would I use him? Yes, sir. Okay, that was that diagnostic on. Go try that again. Remember how we did that? If your R value is not pulling up, that's when you need to do, remember how I showed you guys to go to the catalog, scroll down to the diagnostic on. That's what that's representing, okay? All right. So this one isn't as pretty as the quadratic. So would this be it? Probably not. Does it have good tendencies though? Yeah, it still does, okay? Let's go do the cubic regressions. Once we're at stat, calculate. Let's do number 6. So hot in here. But I'll keep on all my clothes. Okay. Notice r squared is 1, so our r value is 1. So, and it should be because once again it's 4 points. So notice our cubic. Yeah! Go away! Go. It hates me. You guys don't know the pain. Okay, so y equals a value. x cubed, plus 120, 0.53 x squared, 16, 629. Whoa, Betsy. Don't. 62.9? Oh, just straight up 629. Whatever. Okay. Now, in a way, I don't like this equation as much, to be honest. I think I'd go the quadratic. And the reason being is, if I had zero population, would it make sense that my population was 1,000? Is it 14.1, you said? Does that make sense that our population in the year 2000 would be 1421? Could it make sense? I know this really isn't realistic either, but in the year 2000, negative 295. It was more realistic, though. Really, we know this is negative, but if we're thinking about it in terms of points and growth, how this one, I guess this would work too. I mean, yeah, you had it decline really fast. They must have had a plague or something. And then they grow back up. Okay? I don't know. You get what I'm trying to say by that. So we really do have to look into them. Okay? But I would still probably go with them. So we're going to find the year 2022. So how do we do so again? So I'm going to go to my y equals. If something's in there, we're going to clear it out. What are we going to do now? Bars, statistics, equation, enter, okay? Now, me personally, if I graph this, let's just check it out. Watch how crafty the graph is. Oh, I can't see it. Darn, and what's my y-intercept? 1400, right? So if I hit my window, okay, even my x max wouldn't be large enough. I probably need to go to 30. So let's go up to 2000. And then I'm going to go increments of 20 maybe. Okay, so that's saying there's going to be another plane. Okay, if we get so high that people die off of it. Right? But once again, we want to find the year 2022, so what are we going to do? I personally like to go second, calculate. The table's awesome, but I'd rather just do this and hit the value of 22. So does that even make sense? No, so that's kind of why I'm like, is this really the one I should be picking? Right? So let's go back and do the quadratic one. So what I have to do, though, is, ladies and gentlemen, I'm going to quit out. I have to run the regression again. So let me show you. So watch. Ready? Second, enter. That was the cubic. I don't want that one. I want the one previous to that. So hit second enter again, and it brings back the linear, because I want that one. Not the linear. I want the quadratic. So instead I have to go push all those buttons, I can just hit second enter and go to the previous ones that we've done in the past. Okay. Enter. So there's that equation. I'm going to go ahead and store it again. So I'm going to go y equals. Clearing out though. Bars. Y bars. Oh, shiznit. Statistics. Graph him now. See what he looks like. He's getting really high growth, but he'll just go max. But can we find year 22? So I'm going to hit once again second, calculate. Now, for you to do this value, you have to have your window at least be across the 22. Does that make sense? If I was just 0 to 10, could I put in the value of 22? No, for the fact of the matter, your x values aren't wide enough. Does that make sense to everybody? So I'm going to go ahead and hit a value of 22. So 22, 35. So to be honest, even though the cubic was perfect, it didn't probably have the best regression line for our data. No. So I went off of it, and 0.997 is still pretty good, huh? And I'm going to use the 2235. Okay? Does that make sense to everybody? You think you can do that? You have 8 homework problems today. That's it. Okay? Yes, sir. Okay, am I good? Anybody need me to go over anything? I can go around and play with calculators if you want me to.